So let's go ahead and just start off with your background. Maybe you want to tell us a little bit about yourself.
Yeah, I am a final year PhD student at UC Berkeley. I'm in the EECS department, and my research agenda is broadly building AI-powered systems for unstructured data processing. So what this looks like is on a day-to-day basis, I talk to my colleagues about very exciting problems. I write a little bit of code, I write papers, and then I get to go and present them at conferences.
Awesome. You want to maybe just tell us a little bit about, sort of your time in undergrad, how you first got interested in research?
Yeah. I did not know that I wanted to do research. So I did my undergrad at Stanford,
Mm-hmm.
majoring in computer science. And I just kind of took all the classes that I could. I really wanted to take a class in every area, such as, of course, AI and systems, networking, and whatnot.
Mm-hmm.
And I also tried to explore kind of anything that was available to me extracurricularly. So, for example, I was part of a few like CS hackathon like clubs.
Mm-hmm.
Um, and then someone just told me to do research because that seems to be like a thing that undergrads explore. So I was
Mm-hmm.
like, whatever, I'll try it. Sounds exciting.
Mm-hmm.
And I really liked it. I worked on a few research projects, nothing very fancy or special. I worked on a computer science slash music research project in
Mm-hmm.
my undergrad.
Mm-hmm.
Um, that was very exciting to me. And then I also interned at Google. I actually interned at Google Brain the following summer, and I worked on adversarial examples research. But that
Mm-hmm.
was more in core AI. But I really love the process of, kind of working on a problem. Nobody really knows the answer. You're reading a lot of papers all the time,
Mm-hmm.
trying to come up with something and communicate that in the most exciting way.
Mm-hmm. Awesome. And I guess like throughout undergrad, you mentioned how you were involved with various different things. You were also, sort of engaged in a few different internships, like you were a SWE intern at Facebook. I think you did like some research internships at Google Brain. Maybe just tell us a little bit about your experience in industry through internships and how that sort of shaped your decision to get a PhD.
Yeah, so I actually worked a little bit before I did my PhD,
Mm-hmm.
and that was because I enjoyed my internships.
Mm-hmm.
So when I did SWE, I thought it was fun. I was building things. I was working with people. At the end of the day, I just like building cool things and working with people.
Mm-hmm.
Um, and then my research internship at Google Brain was a little bit different because I
Mm-hmm.
wasn't like shipping production code. I was
Mm-hmm.
doing research, writing papers.
Right.
Um, but working full time in industry after graduating made me realize like, oh, I miss doing research. I really
Mm-hmm.
enjoyed doing that. And maybe I should do a PhD because I feel like something is missing from my like day to day job.
Mm-hmm.
Um, and I started doing my PhD, and I really liked it. Even now, I love it. I think it's like the best job on the planet for me. I'm trying to be
Mm-hmm.
a faculty.
Mm-hmm.
Um, so that was clarified for me. It's not like I didn't it's not like I disliked anything a lot. It's just that
Mm-hmm.
I really found that I love doing research.
Mm-hmm. Yeah, it totally makes sense. And I think, in your decision to get a PhD, you are now advised by like Aditya Parameswaran, for instance. How'd you end up like
Mhm.
sort of choosing your advisor and like maybe walk us through your like the first few years of your PhD?
Yeah, I think it's a great question, how to choose an advisor, and more people who are applying for PhDs really need to seriously consider the question. Um, so what I did when applying, and I was in industry,
Mm-hmm.
so I was not, I already had a job.
Right.
I wasn't like searching for other jobs, so I had a little bit more time to do applications,
Mm-hmm.
and I only applied to very few schools because I
Mm-hmm.
thought that, if none of these pan out, I'll just stay at my job and it's like
Right.
not the end of the world. So I applied to three schools.
Mm-hmm.
It's a little bit, not everyone should do that. But
Yeah.
because I only applied to three schools,
Mm-hmm.
I was able to really research some of the faculty,
Mm-hmm.
read a bunch of their papers.
Mm-hmm.
And what really stood out to me about Odysseus research was that it was truly, looking at the similar problem from
Mm-hmm.
multiple different angles. For
Mm-hmm.
example, he will apply like a database, he'll put on his database hat and try to solve a problem, or sometimes it was an HCI approach.
Mm-hmm.
Um, and I felt like, there's not that many faculty out there that are really embracing this kind of disciplinary approach.
Mm-hmm.
The other thing that I really liked about Odysseus' work, it was like very clearly towards a vision, where you could
Mm-hmm.
get that in all of his papers. He built scalable data systems.
Mm-hmm.
Three words to describe all the work that he does.
Mm-hmm.
And I thought, like, okay, if I'm doing a PhD, like, I too want to have a very concise vision. Still quite expansive, right? A lot of different projects under there. Um, But I really like that approach and style. And I think
Mm-hmm.
when coming here to Berkeley, I talked to other faculty as well. And I thought about maybe collaborating with some of their students.
Mm-hmm.
Maybe I spent like a year kind of exploring. Um, but working with Aditya was by far like the most enjoyable for me. And
Mm-hmm.
he's my advisor.
Awesome. So yeah, I mean, you've been involved with a lot of stuff, which we'll get to, but maybe we can start off with your research. So I guess like your research agenda is to build reliable and efficient AI-powered data systems, including like query optimization algorithms, and interfaces that help users specify their intent and trust their results. And there's a bunch of different projects you worked on, but maybe we can start off with one of your projects called DocETL. Maybe you tell us a little bit about this.
Yeah. So about in 2023, large language models like kind of took over the world by storm, right?
Mm-hmm.
People were starting to use them on a day-to-day basis. And one of the biggest problems in data management, data processing is making sense of unstructured data.
Mm-hmm.
Think like transcripts, long form texts, PDFs, stuff
Mm-hmm.
like that. And
Mm-hmm.
people have very complex queries that they want to do on them.
Mm-hmm.
For example, they might want to look at all their customer reviews and
Mm-hmm.
figure out what are some common pain points in them,
Mm-hmm.
create summaries of them, create actionable insights, like whatnot.
Mm-hmm.
So large language models seem like a very exciting primitive to put in data systems. So this DocETL project that we started asked the question of, okay, what does it look like to build a declarative data processing interface where the
Mm-hmm.
operators are executed by LLMs? So
Mm-hmm.
if you're familiar with, for example, Spark or MapReduce,
Mm-hmm.
right? Imagine you're writing a map or a reduce or filter or whatnot, but the LLM is executing the operation. So what that
Mm-hmm.
allows for, it's like you to specify very complex logic, like
Mm-hmm.
map over each document and generate themes,
Mm-hmm.
then group by these themes and
Mm-hmm.
create summaries. So that is the origin of the DocETL project.
Mm-hmm.
And the first thing that research contribution that came along with it
Mm-hmm.
was identifying, okay, how do you do query optimization here?
Mm-hmm.
Like you don't want to pay for an LLM to go through every single document or the most expensive model, reasoning models to look at every document, right? You
Mm-hmm.
can't do that at scale.
Mm-hmm.
So how can we, figure out what the most accurate way is to process these pipelines and then make that cheaper?
Mm-hmm.
And I think like that is really the whole goal of query optimization in this space.
Mm-hmm. Awesome. You also had a paper or maybe a project called Doc Wrangler. You want to maybe tell us a little about this?
Yeah, so Doc Wrangler was actually born out of people using the DocETL project
Okay.
and struggling to write DocETL pipelines.
Mm-hmm.
This is different than trying to write Spark or
Right.
Pandas because you have to write prompts. You need to kind of specify your
Mm-hmm.
complex task
Mm-hmm.
in these map and reduce operators. It's not as simple as, just signing your favorite pandas function and just
Mm-hmm.
writing it and
Mm-hmm.
executing it.
Mm-hmm.
So what that necessitates is you need this kind of playground-like layer on
Mm-hmm.
top of the data processing stack to make sense of what's going on, what's your data, what do you want to specify, how well
Mm-hmm.
is the LLM doing it, whatnot. So
Mm-hmm.
that's the Doc Wrangler interface.
Mm-hmm.
Um,
Awesome.
yeah,
And then you were also involved with like Spade and EvalGen. Want to maybe tell us a little about that?
sure. These are projects that we did before DocETL, in the process of building DocETL,
Okay.
actually. So
I
I
see.
mentioned a little bit about how in DocETL, when we were doing query optimization, we're trying to figure out the most accurate way
Mm-hmm.
to execute the user's pipeline.
Mm-hmm.
The part of doing this is because LLMs are very error prone, they're inaccurate, you
Mm-hmm.
kind of need to have constraints on their outputs.
Mm-hmm.
So if it fails to extract, 3 or more themes, then you need to retry the operation or you have to figure out a different way to specify it.
Mm-hmm.
So Spade and EvalGen are like kind of constraint or assertion generators that you
Mm-hmm.
can kind of bolt onto any pipeline-like system.
Mm-hmm.
Spade is on the data processing side, how
Mm-hmm.
do you infer what these constraints should be?
Mm-hmm.
And then EvalGen is how do you do that in a human in the loop way? So how do you automatically create evals and assertions
Mm-hmm.
with an interface so the human can kind of grade outputs and then you can derive these evals from them.
Mm-hmm. Awesome. So I guess one other thing that you've been involved with, in addition to research, is teaching. At Stanford, you were like head TA of CS 106B. At Berkeley, UTA data engineering. Now you're like co-teaching AI evals for engineers, with Hamil Hussein. Maybe like tell us a little bit about your interest in teaching and sort of how that's playing into your future.
Yeah, I've always been interested in teaching. I think it's pretty fun to do.
Mm-hmm.
It also helps me become a better communicator and a better computer scientist.
Mm-hmm.
So I did it mostly in undergrad, actually,
Mm-hmm.
not as much in grad school. What got me into wanting to teach AI evals was because I found that through the SPADE and eval gen work, actually, and
Mm-hmm.
working with many companies or people actually trying to develop evals and assertions, I realized like this is actually a really hard job. It's not very similar to
Mm-hmm.
evals for traditional machine learning. It's not similar to unit tests for software engineering.
Mm-hmm.
It's kind of like a different set of skills you need to apply.
Mm-hmm.
So it was a cool challenge for me to think, okay, like if I had to teach this concept,
Mm-hmm.
how would I do it? What's the curriculum you need? What are the skills you need? So we teach error analysis and data analysis. We teach how to codify those into unit tests. We teach about how to create LLM judges that you
Mm-hmm.
can actually trust. Like all of these new skills that have emerged
Mm-hmm.
from evals for LLMs. And I think that kind of snowballed into actually teaching a course. Like now
Mm-hmm.
that I've been thinking about it for a while, and
Mm-hmm.
my friend Hannibal, who actually does consulting, he's like
Mm-hmm.
worked with dozens of companies helping them do evals. We were like, let's team up and like let's teach this to people.
Mm-hmm.
It'll save both of our time and energy because we spend a lot of time
Mm-hmm.
telling these same things over and over. And we were so shocked at how successful it got. And I
Mm-hmm.
think it really speaks to this is a real new skill that people need to learn.
Mm-hmm.
Um, and based on this, I realized like I really want to teach AI engineering more broadly,
Mm-hmm.
especially when I become faculty.
Mm-hmm. Awesome. Like broadly, I would sort of categorize teaching into two categories. One is like teaching classes, and the other one's like mentoring people and mentoring students.
Yeah,
And I think you've also done an exceptional job of like mentoring a lot of really, really incredible students. Maybe just tell us a little bit
yeah.
about your experience doing that, because I mean, obviously some PhD students do mentor, but I don't think many people mentor nearly at the volume that you have. And sort of your experience doing that and things you've learned.
Yeah, I've gotten very lucky. I mean, I think I get to work with really talented undergraduates and master students here, being at Berkeley,
Mm-hmm.
and I see mentoring as like the an opportunity to distill like whatever I have learned. Like, how can I pay that forward? Because people have done that for me my entire life,
Mm-hmm.
and I think doing that as a PhD student is also very exciting because there's concrete things that you can do in this mentoring, right? You can like onboard somebody onto a research project and really expose them to this new world of research, help them figure out what they want to do. Sometimes,
Mm-hmm.
many times, I've mentored students who have gone on and done a PhD afterwards,
Mm-hmm.
and they don't know that they're going to do a PhD, and
Right.
then they apply and then they do it, and
Mm-hmm.
that's very rewarding. I feel like it's
Mm-hmm.
also why I'm interested in being a faculty, like
Mm-hmm.
to do it at like a scale that's a little bit larger,
Mm-hmm.
um, and with PhD students kind of turning into
Mm-hmm.
whatever they want to be, faculty, industry members, or whatnot.
Mm-hmm. Awesome. So sort of like looking into, like, I guess, like, sort of the way that you ended up shaping your research to focus on these like efficient AI powered data systems. We talked a little bit about, some of your experience in industry, and I think now at this point we've talked about some of your projects. Like what would you sort of say is your advice for people that are thinking about coming up with research directions? It feels like in many ways, your research is highly industry applicable, especially now with like a lot of the LM stuff. And I think some of your systems have also like influenced a lot of other evaluation tools in industry. So how would you sort of, recommend PhD students that are still trying to figure out sort of what research directions to pursue?
This is a great question. Everything that has all the origin of my like successful projects that I've had is there was like a real need that I observed
Mm-hmm.
people having in industry in some way. And I think I
Yeah.
developed that skill of being able to find it through working before my PhD,
Mm-hmm.
as well as I do some HCI research as well.
Mm-hmm.
And I develop like methodology to go like do this kind of need finding,
Mm-hmm.
understand what are like real concrete challenges.
Mm-hmm.
And I think it's important to do that isolated from whatever's the hot technology or hot topic.
Mm-hmm.
So for example, with the DocETL project, like nobody was saying like, oh, I want to apply LLMs to unstructured data in this map reduce like way
Right.
at that time.
Right.
People were saying like, oh, I have a lot of data and LLMs seem to be a good fit,
Mm-hmm.
but I'm struggling to make it work.
Mm-hmm.
And that I thought was an extremely interesting problem,
Mm-hmm.
right? Because real people are having it, like
Mm-hmm.
people in different industries want to make sense of their unstructured data.
Mm-hmm.
We know that it's been a problem for decades.
Mm-hmm.
If you actually read the literature in data management and
Mm-hmm.
databases, this has particularly been a type of data we've not been able to unlock value from.
Mm-hmm.
And then the solution is not straightforward.
Mm-hmm.
I think that's the other sign of like a very good research direction, which is
Mm-hmm.
like you don't actually know what the solution should be, right?
Mm-hmm.
Like one leap that we made was like, let's try to put this in like a MapReduce or data processing like framework, right?
Mm-hmm.
That's one type of solution. We didn't build a chatbot.
Mm-hmm.
We didn't think about RAG or whatnot.
Mm-hmm.
Um, so I think like these are kind of signs and smells of what I look for
Mm-hmm.
when looking at a research problem.
Mm-hmm.
Kind of, is it real?
Mm-hmm.
And can we prove that it's a real problem in some way?
Mm-hmm.
And the solution space, it should not be obvious at all
Mm-hmm.
what it's
Mm-hmm.
going to be.
Yeah, yeah, I think all of that makes a lot of sense. I guess like in
And
the
I
end.
think it's
Mhm.
different from when you're doing a startup. The
Mhm.
solution should be a little bit more obvious. Like you
Gotcha.
kind of know what you want to build.
Mhm.
A
Gotcha.
lot of people ask me like, why don't you do a startup or whatnot? And I think it's because like I
Yeah.
don't, you know,
Classic
I'm
Berkeley.
excited by the problems where I like you don't know what to build. Right, that's the research project.
Hmm. Yeah, I mean, I think one thing Berkeley's done an exceptional job of is like sort of fostering this like startup community mentality. I think they've done a good job with like CSGE, which for people who don't know, there's
Yeah,
Computer Science Graduate Entrepreneurs Organization. But even beyond that, they've just done a really good job. So I guess maybe just like being a PhD student at Berkeley, having like all this experience, interacting with Berkeley students, what would you sort of say? I guess obviously entrepreneurship is maybe one thing that makes Berkeley different. What are sort of like, because you've been at Stanford and Berkeley, which are two very entrepreneurial schools, how would you sort of
yeah.
compare and contrast them?
Yeah, so it's very hard to do given that I
Yeah,
did my undergrad in one place
right.
and then like took time in between and then do my grad at another place.
Hmm.
So like I'm a totally different person, of course, than I
Of
was
course,
10
yeah.
years ago.
Yeah,
And I'm not an undergrad here.
yeah,
But I will say, like at a high level, I really like that in Berkeley, the research is Berkeley is world class in research in so many areas of
right,
computer science.
right.
Like every area of computer science is very well represented at
Yeah.
Berkeley. And that's not something I felt like at Stanford. I felt like
Hmm.
Stanford was very, very good at AI, and there were certain faculty and other disciplines who were very good.
Yeah,
But you can't like reliably say every. So, for example, Stanford
yeah.
doesn't have a database group right now. So
Wow, okay.
I thought it was not a bad or good thing or whatever, but I felt like coming to
Interesting.
Berkeley, I was like, oh, I'm
Yeah.
here. I really want to make use of the fact that it's just so world class and everything. I want to try to collaborate with many people, take classes in those areas and so
Hmm.
forth.
Gotcha. Gotcha. Very cool. Okay, getting into some of the other things that you've done. So I think we've hit some of your major projects already. I think you had a paper titled Cut Costs, Not Accuracy, LM paper, Data Processing with Guarantees. I know this one, I guess, hasn't yet appeared, but it seems like it's very recent and might be relevant. Want to maybe tell us a little bit about this?
Yeah. So this is actually my colleague Seb did like all the work,
Oh, that's
and
okay. That's okay.
I don't know. My
You
role
can
was
still
like a
cover it.
cheerleader in
Yeah.
in this project. But broadly speaking, right, when we built DocETL, we realized like there's this world of LLMs for unstructured data processing, and of course,
Mm-hmm.
one problem that we've been studying through DocETL is how do you make sure it's accurate and
Mm-hmm.
reliable.
Mm-hmm.
The other angle is how do you make sure it's efficient.
Mm-hmm.
How do you do cost optimization?
Mm-hmm.
And Sep's paper here on this cut cost not accuracy is really exploring this angle of like, okay, how can we reduce costs by like 10x to 100x?
Mm-hmm.
And we actually have a follow-up paper coming out
Mm-hmm.
hopefully in the next couple of months. It's under review right now.
Mm-hmm.
But there's like all the idea is that cutting costs is a problem. How do you do it by maintaining like 95% accuracy or more?
Mm-hmm.
Can you do this provably? Turns out you can. You apply
Mm-hmm.
some theory,
Mm-hmm.
and you can save a lot of money.
Awesome. I think you have another paper titled Prompt Evals, a data set of assertions and guardrails for custom production large language model pipelines, which you also co-authored with some of the folks over at LangChain. Maybe just tell us a little bit
Yeah,
about this one and that collaboration.
definitely. So maybe a couple years ago, and still this was just like in building DocETL, and this was thinking about like how do we automatically develop guardrails
Mm-hmm.
and evals for these data processing pipelines. one collaboration that we had with LangChain, which is really, really fun, was like LangChain has all of the data that you would want. Like they
Mm-hmm.
have all the pipelines that people build.
Mm-hmm.
They have all the versions of all the prompts of those pipelines.
Mm-hmm.
And what you can do is like you can really figure out like what kinds of constraints do developers care about when you mine that really, really rich history of pipelines.
Mm-hmm.
What are the applications that they use and so forth. This goes back to, really trying to embed yourself somehow with industry to figure out what are the real problems to solve.
Mm-hmm.
So with LangChain, they were very, very excited about the idea of open sourcing such a data set as
Mm-hmm.
well. So, of course, with permission and everything.
Mm-hmm.
So, this prompt evals data set was a collaboration with them to take the real pipelines that developers have written.
Mm-hmm.
And this is like an order of magnitude larger than any other data set that's out there.
Mm-hmm.
That people have tried to collect through user studies or so forth.
Mm-hmm.
And we also have evals for them. So,
Mm-hmm.
yeah.
Awesome. I guess we can go ahead and sort of end with a little bit of your sort of general takes on society today when it comes to research. There's a lot of really interesting things
Yeah.
going on, especially around RL environments, as is going on like with a lot of things going around these days. I think your work definitely is more focused on sort of, as we've mentioned before, like sort of the query optimization side of things, and in many ways like sort of like the system of ML in a lot of ways. But I guess like sort of like what are your takes? Like what are some like areas you're really excited about at a high level? Obviously, there's always interesting things coming out of Berkeley. There's a lot of like agent work
Yeah.
going out of Berkeley. I'm sure you have a lot of friends that are PhD students that are just doing stuff across the board. Like
Absolutely.
what are you most excited about?
Yeah, a bunch of things. I think it's an awesome time right now to be in research. I don't know
Mm-hmm.
what other people are thinking, but
Mm-hmm.
there's so much going on, and you
Yeah.
can, with the archive culture and
Right.
Twitter culture, you can like participate meaningfully in the
Right.
discourse, even if you're not at one of the big labs, which I think is incredibly exciting.
Mm-hmm.
In terms of concrete research areas, of course, you mentioned like RL
Yeah.
environments,
Yeah.
verifiable RL are very hot. I personally haven't explored those areas. There are
Mm-hmm.
folks in my lab who are.
Mm-hmm.
Some of the people who sit next to me, the Sky RL folks, for example, I think are
Right.
doing very exciting things, helping to build environments,
Mm-hmm.
to build open source tooling to make it easier for people to do RL research.
Right.
That seems very exciting. Um, Trying to think what else. So there's so many projects going on
Yeah.
in the Sky and Epic Labs. I'm part of the Epic Lab. I'll put
Mm-hmm.
in a plug for that.
Okay.
We work with people in like the law school and the School of Journalism
Mm-hmm.
on like social justice applications.
Mm-hmm.
How do we build low code and no code tools to
Mm-hmm.
help that word? But I encourage you to just check out whatever the Sky Lab and the Epic Lab at Berkeley are doing.
Yeah.
It's a really good time.
Yeah.
Yeah.
Awesome, awesome, awesome. And I guess our very last question here, if you had to sort of, I guess, go back in time and you were an undergrad back at Stanford, this is like before you figured out you were interested in research, what type of advice would you give yourself? Maybe like if you're going back to the beginning of your PhD program, what type of advice would you give yourself? I think, sort of broadly, the audience will include a lot of people that are highly technical, and so a lot of that could be grad
Yeah.
students. But I'm sure that there's going to be some like very curious undergrads that are like very driven to do research. And so for those listening, like I guess
Yeah.
like what sorts of broad takeaways would you want to give them?
Yeah. So for undergrads, one thing I did really well was I took a huge breadth of classes. So my
Mm-hmm.
advisor in undergrad told me to take a class in every area of computer science.
Yeah,
And that sounds really crazy. Like,
yeah,
who's going to take a class in every single area of computer science? There's so many areas and that's so
right.
many classes. But I'm so glad I did that because
Mm-hmm.
I understand computing. Like, I think we want to, as we develop and mature and our field grows, right?
Mm-hmm.
We want to like have a really good grasp of kind of the history of computing and where you think that computing as a field is going to go in the future.
Mm-hmm.
So I wholeheartedly recommend, you know, trying to develop that breadth in undergrad because it's there, you can do it. It's much
Mm-hmm.
harder to do in grad school
Right.
because in grad school you kind of have to go deeper.
Mm-hmm.
But my advice for kind of first year PhD students,
Mm-hmm.
one thing I wasted a lot of time on early in grad school was thinking that I know what's the best project to work on and I'm just going to do whatever I think is interesting.
Mm-hmm.
Like that's great. You can follow your passions to some extent,
Mm-hmm.
but a large part of the process is realizing, like for me in my PhD, it's like I don't know anything.
Mm-hmm.
right? There are people around me, my advisors and everybody who've been here for decades, and
Mm-hmm.
they know a lot of things. And
Mm-hmm.
my job right now is to like really maximize these 5 years of like advisorship and like mentorship and just building a good mental model of,
Mm-hmm.
again, the field of computing.
Mm-hmm.
So don't, if there's a project that you don't immediately think is interesting, but somebody thinks it's a good idea,
Mm-hmm.
or you have the opportunity to collaborate with somebody on something, take it, right? Like explore it. You'll like learn about so many things in the process.
Mm-hmm.
You'll learn how to write a paper, to communicate, to give talks. Like
Mm-hmm.
there are all of these sides of a PhD that
Mm-hmm.
that you can't ever learn before the PhD. And it's a really
Mm-hmm.
good idea to listen to those who are older and wiser than you.
Mm-hmm. Yeah. I mean, I guess like a very last follow on to that, if you had to like sort of drill down on like building community or joining community as a PhD student, like say for instance, we sort of go back in time to like when you had some industry involvement but not a ton of research involvement, and like thinking today where there's like so many different communities, there's like Discords for research, there's
Yeah.
conferences for research, there's like, the Stanford MLSys seminar, there's like all of these different sort of like groups of content or groups of communities and things like this. Like what do you think are, I mean, obviously there's like infinite out there and like it depends on your research area and stuff, but maybe we can take for instance like your research area, like what sort of advice would you give to people that are looking to engage with as many collaborators and like meet everybody in the community, like go to conferences, join Discord groups, like what do you think they should do?
Yeah, do everything and try to participate in the discourse. I
Mm-hmm.
think a mistake people made is they don't participate. They like join the groups, they show up to the conferences, but like
Mm-hmm.
they don't talk to people. They don't
Right.
comment on threads. They don't actually say words.
Mm-hmm.
And it's not about, going to the place where there's the most people. It's
Right.
just about finding a very small handful of people that you
Mm-hmm.
can talk to pretty regularly. And then
Mm-hmm.
everything grows from there. So
Mm-hmm.
I would say like, use whatever avenue you can to like make good one-on-one or like small group connections.
Right.
Um, and then things will naturally flow from there.
Awesome. All right. Well, on that note, thank you so much for coming on the podcast. Really appreciate your time.
Yeah, of course. Thanks for having me.